So it's really nice to see everyone here, and actually we didn't expect so much people because it's, after all, Netanya. But it's a really cool place, and I really like these offices. Spark Beyond and Toloka are like partners for over a year now, and we decided to do this meetup because there's like a upcoming boom of machine learning and AI in Israel is one of the leading countries that pushes all of it. And just a second. So today you're gonna have some really interesting talks. As I mentioned, Spark Beyond, who were gracious enough to host us here, and there's great spaces of them. Shai is going to speak about the great product called Nomi in the area of knowledge mining, and what he did also with Toloka, using Toloka to power his AI tool. Itamar from BrightData is going to show their great data collector and talk about their services and vision, and also we'll show a nice project that we did together for this meetup and going forward. And last but not least, Orcam is going to show a great product that Olga was speaking at one of the summits together with Orcam, and we saw that product and we thought this is a really cool thing to show also here. So without further ado, let me give the microphone to the first speaker, Itamar.
קליקר למצגת, נתחיל? קליקר. תציג את השקף הראשון. עומר? אתה יכול להפעיל לנו את זה? כן. אתה מחובר לזום? איך לזום איתך? מהקלנדר. ולעשות share? כן, קודם תתחבר, אני אשאיר אותך. תודה. Recording in progress. כן, לא צריך טקסטים וכאלה. זה אחלה. Hi everyone, my name is Itamar. I'm from BrightData. I'm the director of data product in Bright. And today we are going to speak mostly about how to master web data collection. I know that you came for a slightly different thing for NLP and maybe train AIs. But today we're going to speak, I guess, on the first thing that you need in order to train any kind of AI or any kind of NLP that I guess you are all aware but never really thought about it. Do you have any idea, without reading it, you're cheating, do you have any idea what is the largest database in the world? Without reading it, guys, don't read it. It's cheating it.
It's too late.
It's too late. So what is the biggest database in the world? No. The internet. So the internet is really the biggest database in the world, and we in Bright collect data from the internet, publicly available data. As you can see from this graph, that in 2010 there were just 2 zettabytes. It's a lot of zeros. Check it in Google. A lot of zeros of data. And in 2025 we're going to talk about 181. What was the time that COVID started? 2019, something like that. March. I think the first case was December. 2019. So look at the numbers. Look how it's growing since then, because a lot more people are using the internet. They cannot do it any other way. So of course, by doing that, and a lot more people are buying from e-commerce website, etc. So it's just making everything bigger. 2 weeks ago, I was super excited. You don't even understand how excited I was when the CEO of my company sent me this. The Warner Vogels, I guess that not a lot of people know who this guy is. So he's the CTO of Amazon. Like Amazon is like maybe the biggest company in the world today. He posted in Twitter a tweet about why Kilcher, yeah, why Kilcher. Maybe some of you know him. So he's someone that we collaborate with him, and he created. This guy created a video of how to collect data from the internet, and then with the data that he collected, he trained. I will show you what he trained in a second, but he trained a model to create something really, really amazing, and he was so impressed that he had a tweet about us and this guy. So I'm going to talk about what this guy did for us. And I guess that all of you know these monkeys, right? And the most interesting things about these monkeys is that none of them here really exist. All of them are new monkeys that were created automatically by a machine. But after someone, White Klitcher in this example, collected all of the monkeys that exist in one website and then created a model to create them. So really fast. He did it by going to this website. Here you can buy all of these monkeys. Now, I guess that this thing is not really working this well. I know it's like decreasing in popularity, but still, he collected all of these images without technology. And he did it by using something that we are calling an ID. So we have like a system that with simple JavaScript, we can scrape any website. We can unblock any website as well because site will block you if you do it in scale. He downloaded the image as well with our system. We are downloading the images and sending it to the customer service. It can be to Amazon S3 bucket or to Google Drive. And then he created this thing. It's a very funny video, by the way. You need to look at it. And I don't know a lot about how to train AI. Maybe you know better than I. But he said something about training the gun. This is a gun. What is a gun is? I don't know if I have like a laser or something here, but so this is a gun, a generative adversarial network in class of machine learning frameworks. And after he trained it a bit, he taught me something that I didn't know, that in this thing, we need to be as low as possible. In most of the graph that we are looking at life, we need to be as high as possible. But if you are getting here, you're doing good, and here he did something bad when he tried to train it. And the result of the training was that this was the result. As you can see, it's not good. No one can understand what's going on here. So we keep training it more and more. After a few steps, he got this thing. So you're starting to see monkeys. It's not really like a good one, but still, you're starting to see something. And after he went to step 9,000, we are starting to see real monkeys here. I guess that our presentation will be sent later on. So if you have some time, first look at the video. It's a funny video. It's talking about things in a really hilarious way, in a good way. And second, if you want to create your own monkeys, click on this thing, and then a monkey will be created with the AI that he created. Now, a bit about BrightData. The reason that we invented the data collector product is because most of the companies that we are working with today, we're working with more than 15,000 companies. 7 out of the 10 biggest e-commerce companies in the world are working with us. A lot of Fortune 500 companies are working with us, and also smaller customers, but still all of them has the same problem. First problem is that sites are keep getting changed. So when you want to download something in order to create a structure, a data set in order to train your model, you can do it today, and maybe later on the site will change, and then it will stop working. So we are helping you with this part. Second thing is that when you're trying to do that in scale, you will get so many issues along the way that you will just say, I don't want to do it anymore. One of the things is a blocking issue, and we have two kinds of blocking issues. We have a hard block and a soft block. Hard block, no block is good, but it's better than a soft block because when we're talking about hard block, at least you know that you are blocked, like seeing a captcha and then you can solve it, or you're seeing some kind of error saying, I know that you're a bot, stop, and you can do something about it. And this is what we are doing. We are doing something about it. We have the best technology in the world to unblock websites. The second thing is a soft block, specifically in travel industry, and also with some other industries. You will just see bad data, and this is even worse because you don't know that you are getting bad data. Just one example of it: think about yourself trying to buy a flight ticket, and then you're saying that it costs $50 when in reality it costs $20. So this is maybe because he detects you as a bot, so he's lying to you until you really try to buy a flight ticket. And the last thing, it's resource heavy. You need a lot of people to do that, just to collect the data. And I guess you all understand that we are living in a time that you need to do things fast and you need to focus because there are a lot of things to do. So when you're focusing on training your AI or NLP, I hope that you'll want to outsource the part that is hard, but I guess in the end, everyone will get it. It's the data itself, so you can outsource it to us and we'll just collect the data for you. I don't know if you know that, but if you want to collect, as an example, 20,000 products, and you have just 2 browsers, and let's say that it will take you 10 seconds to collect it, it will take you 27 hours. It's a lot of time, and no one wants to collect 20,000 something. It's nothing. You want to collect millions. So then you need a large infrastructure, a huge infrastructure in order to do that, and we are doing that on a daily basis. A bit about what we are doing. So everyone that collects data today, in order to do something, have like 3 options or 3 states to the pyramid. So one of them is server and crawler code. When you are writing your crawler, your scraper, or however you want to call it. On top of it, you have proxy. We invented something called residential proxy, by the way. This is our patent. We are doing it in a way that we have more than 72 million IPs all around the world that we can use in order to collect data from. So when you're collecting data, the data is like real data, as someone from the US is trying to collect it, or trying to see it as a customer. On top of it, we are unblocking any website and parsing it and interacting with it in order to give you the right one. So this is what the data collector do. This is part of our popular use cases. So if it's something that you're doing, we can talk about it later. We have 2 guys here from Bright that you can talk with them as well. This is part of the data sets that the customers are collecting with us. And a bit about what we are doing. One sentence, imagine Instagram. All of you know what Instagram is. This is a page, a regular page, and it's unstructured. And imagine that you have some millions of other layouts and pages that you also need to structure. So we are taking this and creating a data set out of it. So in this example, we are taking the profile picture, post, followers, info, etc. By the way, we're also downloading images and sending it to you. So if it's something that you need, we are doing it. How we are doing it? Behind the scene, we have an IDE that everyone can join a Bright after it, sign up, and just do it yourself. So we are writing a code in JavaScript. What you're seeing here in this part is like a real page that's running in the background. We are creating a browser. We are clicking on a lot of objects, interacting in a page in a specific way that you, the customer, are telling us to do. And in the end, after we are getting to the right page, to the right screen that we want to collect data from, we are using the parser code in order to say, I want this, this, and that in this specific structure. And then we are creating the data set. This is just one line. We are doing it like millions of times for every website. And we are delivering to you in multiple ways: JSON, CSV, MD-JSON, Excel, and to any kind of storages. It can be Amazon S3 bucket, Google Cloud Storage, Azure, FTP, API, Webhook. I forget something? No, I think so. And this is the end result, a data set in CSV in this case. We can do it also in JSON, etc. So we created a lot of function to make your life a bit easier. So if you want to do it yourself, there are tons of function here, like hover on top of element, navigate, use different IPs from different websites, from different countries, Click on it, super easy. And if you don't want to do it, we can do it for you. The thing that we will give you in return is first a schema. So if you want to collect the same data from multiple websites, just tell us what's the schema for all of these websites. So just one example for it. Let's say that you want to collect data from e-commerce website. So it doesn't really matter if you collect it for Amazon, eBay, Walmart, whatever. You will always want to collect title, prices, maybe reviews, all of these kind of things. So this is a schema that will be relevant to all websites, and then you'll have just one structured database that you can use for your own purposes. On top of it, we are doing data validation. We are checking that the data is not just in the right structure, but also the data itself is correct. So let's say that you want to collect price, we will check that the price is really price and not something else, or that it exists and not something else. And on top of everything, you have our control panel dashboard that you can look at all of the collectors that you have that are installed on your account and what's going on with them. Look at the statistics, look what's going on now, if now we are collecting something or not, etc. And it's not doing anything. Can you click on it, maybe? Yeah, we're getting to the fun part. Yeah, okay. Yeah, okay, thanks. So this is the fun part. So I guess that everyone know this guy. He's kind of famous, right? So, so, so this is, so this is Elon Musk. From the crowd said that he's a troublemaker for the ones that are at home or at office. So we did a collaboration with Toloka to try to do something really, really nice. It's sentiment analysis, meaning that we collected the data, all of these tweets, and then we send it automatically from the system to Toloka that did a sentiment analysis on all of these tweets to say if it's positive, neutral, or negative. This is our CP control panel. I can't show it to you because it's not for my computer, but register to BrightData later on, talk to me, talk to any one of our guys, Daniel. And you see, raise your hand, so you can talk with both guys here. They can help you sign up and create your own CPs. So we created the CP. Just before I started, like 2 minutes ago, I ran it again just to see what's going on, and I saw that this is a tweet from yesterday. He's today, I guess, so almost, yeah. So he's saying that YouTube seemed to be a non-stop scam ads. This is maybe his latest post, his latest tweet. It's from Tuesday, June 7, 3:32. He got 49,000 replies, 42,000 retweets, and 532,000 likes. About YouTube seems to be non-stop scam ads. So super famous, and he's doing a lot of things. And what we are doing for companies that are collecting social data in this case is helping them collect all of the data, also on specific tweets, like to see more data about replies, retweets, and likes. And in this case, we send it to Toloka that created a nice project to connect between our way of sending the data, in this case, a webhook, to their system. Their system got it. And then, David, if you want to say something, please do. And then he created like 2 things here. First is a test to give to their labelers to see if they are doing correctly, like if they're doing right and if they are good for the job. And after they pass the test, they give them the real test of doing the sentiment analysis. And this is what you're seeing here. And for this X tweet that we collected, we found out this, that between the 26 in May to June 3rd of June, 4 tweets were negative, 18 was neutral, and 11 was positive. And from then it got a lot more negative with the YouTube scam and stuff. Yes, sir. Automatic, their tags? Automatic by their labelers, meaning the process itself is automatic, but someone looked at it and saying if it's like negative, yeah.
This one actually it's full manual.
There is some correlation between the tagging and the likes or anything, the retweets.
Yes, there is correlation, but it's not something. Yeah, can you repeat the question? Oh. Me or?
Yeah, just ask the question.
Is it manual tagging? First question, and the other one is there is some correlation between do manual tagging and likes, retweets, and sharing, that it must be. Thank you.
Yeah, that's okay. That's a good question, actually. The tagging that you're seeing here is actually manual. We wanted to show the statistics. We didn't show the correlation. I'm sure there probably is, but we also have one of our models, and we will show it in the end. So you will have something nice to stay for. We will show actually a model that ran on 56 million tweets. And when you give it a new tweet, it can decide whether it's neutral, positive, or negative. So I'm sure there is correlation. We just haven't checked it. But that would be a good follow-up with you, maybe. Thank you.
So, yeah, please.
What does the system do with the sarcasm? For example, like the Morbius movie, when everyone says it's the best. But so what would the system say here? Is it positive, negative? When the tweet is positive, but the meaning is negative.
Thank you for the question. So, like somebody in the crowd says, it depends on the model. But ultimately, I think that the one that we trained is pretty, say, like childish, maybe like naive. So it will give you it won't detect sarcasm, but I'm sure you can train a model to go even further and also detect sarcasm. Thank you.
Click again on the. Thanks. So, so this is just one collaboration that we can do with Toloka, and we can do any other thing that is connected to giving task to someone that will look at the data and do something with it. If you're interested in collecting web data and then doing whatever you want with it, I guess that all of you are from different companies and all of you are doing different things with the data that we collecting. So one model is doing it yourself, like I showed before with the IDE. Just write your own code in JavaScript and do whatever you want with it. The second part, if you don't want to do it, and most of our customers don't want to do it with it, they want us to handle all of these things. You can just go to our control panel, request a collector, tell us exactly what you need, give a project a name, tell us from what website you want to collect, exactly what to collect for. And immediately after, you will see this tracker. The motivation, or we thought about Domino's Pizza, they did it first. When someone is ordering a pizza, you're saying like a tracker to see what's going on with your pizza. Someone looked at it, now it's in baking, someone is doing something, it's delivering, etc. So it's exactly that. After you're asking it, you will see a tracker to say it's in development, it's ready to test, you can test it. And also if it's pending approval. When it's pending approval, you are looking at the data itself, at the JSON in this case, and you're saying if you want to improve it or say that something is wrong and we still need to fix it, and then we will, and then we'll send it again to approval. And after you're done, you have your own collector that you can run in any scale and to collect any kind of web data. So this is the time the questions, and someone wrote something in the audience, so maybe you want to show it.
Does the labeling you do, it's a property of the company who orders it, or it can go to?
To answer to the same question. So first of all, we in Bright are just collecting the data, and we are creating a collector that is relevant specific for you, and then the data is yours. We are sending it to you. The labeling, it's the Toloka part, and they will explain.
Yes, can you repeat just the question?
The answer is the same, actually. I was just answering.
I was wondering if the data I'm asking for is available for other companies from the same industry, or they have to do it all over again?
In Toloka, you mean?
Yeah.
No, actually, every requester belongs to the requester, so we don't use it in any way. We're not allowed.
You can't like resend it or
No,
redistribute it.
it only belongs to the requester, and we just facilitate and give the best tools in order to get the best quality out of this data.
So you like do it twice or more if necessary, the same job?
You mean the labelers?
Yeah.
Actually, we usually do planning for every use case. One of the biggest steps, one of the first is the composition of the task. So you can break it for a big task, you can break to several different tasks, and that actually ensures that the quality that you get is, I guess, like the higher that you can probably get. So we have actually, yes. So we specific what? Yes, sir. This is by the way, just let me introduce you. So this is Olga. She's our CEO and founder, and she will answer the question.
Thank you, and that's why I just cannot be silent. Sorry for that. So the answer about like all the data labeled on Toloka belongs to the requester. The second part, what do we like kind of resell or do repeated tasks? There are two parts. First of all, when we see repeating trends, we create some templates which can be reused by different requesters to easify for every next requester the step in. But at the same time, in general, what we see is in reality, almost never you would find two repeating cases. Every requester has some specialities, some particular cases they want to fine tune for themselves. And that's why like it's really, we would be happy if we could standardize everything, but unfortunately we don't see it possible. And that's why like every day on Toloka, there are more than 1,000 different projects running. And probably our life would be easier if there were like 2 or 3 of standardized cases, but in reality there are thousands. Thank you.
Any more questions?
Hi. So, is there any way to make sure that the people providing the labels are qualified to do so? And what other quality assurances are there?
Yes, thank you for the question. So actually, Itamar mentioned it earlier. He showed our interface, and one step, which is a prior to the relabeling, is doing a test, doing training first of all, then exam, and assigning skills to people. So only people who pass the exam in a certain like trench or bars, they are allowed to do real tasks. So this is one, I say one of the ways to make sure that the people are qualified. But there are also other quality control rules that we incorporate inside Toloka that can also contribute to the quality of the project and all the people using it. Thank you. Yes, sorry.
What does your name mean? If there is some meaning to your name. Is there a meaning to your name? What's the meaning of your name?
Okay, so Toloka, so the question was, does Toloka mean something? And for this, I would like our CEO to answer the question.
Just wanted a photo opportunity.
Thank you. So yeah, that's one of our favorite stories because the name Toloka, actually the word comes from Belarusian and Ukrainian language. This is the name of the ancient tradition when people used to gather together to do some common job, which is impossible to do by a single person, such as do the harvesting or join together to build a bridge or a church for the village or something like that. And our developers from Minsk, they have chosen this name. Later, we had several attempts for renaming to choose a more global name or something. And every time we came up with the understanding that nothing is better reflecting what we do than the word Toloka, because it's a good allegory of the crowdsourcing.
So, Itamar, thank you so much for a really interesting presentation. And I encourage people to go and try the monkeys, and we'll send later the links. And I would like now to present my good friend and one of our great partners, Shai. He's the director of knowledge mining here in Spark Beyond. And first of all, thank you for hosting us. We really appreciate it. I think it's a really nice setting. And Shai is going to talk about, I think, one of the most interesting projects that we encountered on. And let me invite him to the stage.
Thank you very much, David. First thing first, I'd like to thank people in Spark Beyond who helped us organize this this meetup. So thank you, everyone from Spark Beyond. Hi, everyone. Good evening. My name is Shai Hummel, and as David presented, I'm the director of knowledge mining here in Spark Beyond. Spark Beyond empowers companies with the AI-powered solutions. Today, I'm going to share our experience with creating an NLP-based engine and the reasons that got us to collect data and increase the quality of the results that we provide our clients. So first thing first, I will present the platform which uses the NLP engine. The platform is called Research Studio. Then we will dive into the specific engine, knowledge mining engine. We will talk about what led us to collecting data, and finally we will talk about what we did with this data and its effect on the final results. So let's start with describing Research Studio. So Research Studio is a platform for general purpose research. The user of Research Studio provides a subject. The subject may be every subject or any topic that the user wants. It can be, as you see here, solid state battery. It can be a location like Germany. It can be a company like Google. It can be whatever you want. And the researcher may ask any question she would like by providing something that we call relation. The relation captures the question that the researcher is interested in. As the research continues, the researcher may research other deepened stuff. For example, if the original search provided these results, for example, a solid state battery, and the producer is, we see here Toyota and Samsung, and we can ask additional questions and get additional answers. Basically, we change the way researchers are doing research by, first of all, providing the exact answer to the question that they are interested in. If you ask yourself what's the way that you are doing research, you are going, I guess that you are going to Google and going over the first links, and then inside each link you are trying to find the exact answer. The paradigm that Research Studio is trying to implement is one which we first of all provide the exact answer, the most exact answer that we found, and we support the answers with snippets that we found over the web. Actually, it's not just over the web. We are searching over the web, as I told you, but we are also using Wikipedia, patents, research publications, and a lot more data. We have a huge amount of data in-house, which we are using for this system. So behind the scene, we have the knowledge mining engine, NOMI for sure. This is how we call it. So as you probably guessed, knowledge mining, NOMI gets as an input the subject and some kind of a relation. it's doing its magic and returns to the platform the answers, the concrete answers, where each answer is backed up by some evidences, by snippets that we found for that answer. Let's dive into the implementation of the engine itself. So we start with a recall-oriented phase. The recall-oriented phase is one where we go to the databases that we store in-house, and we also go to the web. We are trying to retrieve snippets which are on the subject and related to the subject via the relation. The next phase is, given the snippets that we found, we are trying to extract the answers themselves by using BERT Squad 2, and we extract the exact answer, and it goes with the evidence that provided it. We also add metadata to the answer. The metadata may be Wikipedia linking, named entity recognition, part of speech tagging, and NLI, natural language inference score. The next step is deduplication. As you can see here, that there are cases, and actually there are a lot of cases, where we get answers which probably refer to the same entity, but we don't want to show we don't want to show to the user both Blackstone and Blackstone resources. They are both refer to the same entity. So we have the results go through a deduplication phase, and finally scoring. Originally, the scoring was done based on the amount of evidences that each answer had, which is kind of a good paradigm, or kind of it worked well for a while, and we got very good feedback from our clients. However, our clients wanted more. They wanted to get the top results as good as possible, and they wanted to not, they didn't want to go over the entire list. They wanted to get as precise results as possible at the top of the list. Let's have a short look at how a single output from NOMI looks like. So if the user inputted methane and asked for applications of methane using the relation used for, our user got fuel and a snippet with methane is used as fuel, etc. So it really shows the evidence for that answer. As for the client feedback, once we got that feedback, we knew that we needed to collect data. We needed to collect data in order to increase our precision, in order to make our results better. So let's see the first labeling task that we had. It was a labeling task that we did in-house inside Spark Beyond, and the feedback that we got for that labeling task was, oh my God, this is horrible. I don't understand the labels. And as you can see, the labels here are quite, looks alike. They're textually more or less the same. There's a yes here, yes here, yes here, and one no. So we needed help. We understood that we are not doing the task right. We are not defining it correctly. And with the help of Toloka, we defined a new task. The task was a much simpler task. We wanted to capture the main effect of the system to our user. And in order to do that, we asked us a much simpler question. Given the question, the answer, and the snippet, is the answer correct given the snippet only? We require the labelers not to know anything or disregard anything beforehand. So the new task looks like this. What is methane used for? The answer is fuel. As you can see, it quite resembles to the first task. The snippet is the same, and the only thing that the labeler needed to do is write yes or no. It was a simple yes or no task, and it worked very, very well. Before I go to this slide, I want to say that when we define the task, and this kind of answer one of you guys' questions, when we define the task, Toloka really helped us define the task, define the control question, define the control measures to verify that the task is being done correctly. I want to show you an example. So which company manufactures laptops? And we have the answer Intel. If one want to read this snippet, and this one is used as a test question actually. If one of the labelers didn't read the snippet, and and maybe the labeler has some prior knowledge, the answer to this was yes. But with the help of Toloka, we defined these kind of test questions. And if you will read the snippet over here, you will see that actually Apple is the one which manufactures laptops, while Intel, provides the processors. Another thing that Toloka helped us to do is there are cases where the snippet is very long and has some difficult concepts, which seems weird. And one of the things that we defined in the task was a minimum time for each task. And this is one of the quality measures that we imply in the task. This also helps us keep the quality of the results that we get after running tasks in Toloka. Shortly summing up what we saw thus far, we have Research Studio, which is a platform for general purpose research. Research Studio is using NOMI. NOMI is an NLP-based engine to extract answers and provide evidence for these answers. We needed to improve its quality, and we did it with labeled data. So after a few iterations of running a labeling task over Toloka, we got to 12,000 different labels over 48 different inputs. And we got to a baseline of 76% precision. And we asked ourselves, okay, what can we do with it? It looks okay, but we want more, we want better. And in order to get to do better, we used another product by Spark Beyond. I'm not going to get into the details of this product, but I will say that it's the discovery platform is a product which helps data scientists get new insights by exploring the data and generating a lot of features, trying to find features which really explains the label. And in this case, we also used the discovery platform to explain the data that we got from Toloka. On one hand, we have label from Toloka. On the other hand, we have our data, our output from NOMI, and we wanted to understand what explain the label. And we saw that there are features related to the subject and the answer, and we took them. We also saw that features coming from BERT, the scores from BERT, are also significant. And finally, answers with Wikipedia linking are quite good features. Using XGBoost-based predictor, we trained it, and as we collected more and more data, you can see the precision increases. We started baseline at around 81%, precision at 50, not the overall. The precision at 50 is around 81%, and today we are at around 94% precision at 50. And the precision at 100 acts more or less the same. It also started at around 76%, and we are now at 90% precision. So what we learned from this work. So labeling is hard work, and Toloka really helped us come up with a good task, a good quality for our results, and it went really fast. Data is the new oil. I don't think it's anything new to anyone here in the room. Collecting label data really changed the way that we are doing our work. We have a baseline, we know where we stand, we know that we can analyze it, come up with new features, come up with new insights, and we are planning to automate the entire process of labeling, getting the label, training the predictive model, and deploying it to production. Today it's manually done, but later we are planning to do it automatically. Behind the scene credits and stuff. So Dimion, Tal, Joanna, and Yuval. Yuval is not here, but credits to all of them. Questions? Talk to me.
So with everyone here, can I see? So what other options did you consider besides Toloka? Did you try anything else, or was Toloka the first option that you considered?
So one of the options that we tried is sitting here in the audience, so I'm not sure that I want to say anything about it at the moment, but we tried both. We tried one of the leading providers in the industry back then, and we tried something small. And actually, we got to Toloka by accident, and I think it was a good accident.
And then Toloka came to Israel. A big one. Okay.
Next.
Can I apply this awesome system to an internal knowledge base that we have?
You mean?
Not scraping Wikipedia or so. Given that I have a knowledge base and I want to have this Q&A system that you developed.
Let me see if I got it correctly. You are asking if you can give us your data and run this system over your data. Feature on the pipeline, actually. Okay, thank you.
No. We have time for one more question. If anybody
okay.
in the audience.
Yeah, of course. People.
So I assume you have a duplication in the labeling. What did you do with this incident of duplication? Because labeling by person, it's a bit
This is a good question. So we encourage actually duplications. Each question that we ask is labeled by 3 to 7 people, and we are doing it in order to increase the confidence we have in each answer that we get from Toloka. And again, this entire well, I was previously aware of this this feature, but for example, measuring the time to answer or the getting the right person for the task is something that Toloka configured for us with the features that they have. So a lot of there are a lot of features inside Toloka, a lot of conditions that you can set in order to verify that that the confidence is high, the confidence that you get. Yes, actually, it's automatically. Okay.
No.
Okay. One final slide. So please.
Yes.
Final slide. So we are we are hiring, and we have open positions in Spark Beyond, and specifically in the NOMI team, we are hiring a Python engineer and senior NLP and junior NLP. So come work with us. It's fun. It's very, very interesting. We'd appreciate if you.
Thank you, Shai. I'm really sorry, but you will have time to speak directly to Shai. You can ask him whatever you want, but we need to proceed. Okay, so thank you, Shai. It was really, really interesting, and thank you for supporting Toloka in this event also and hosting us again. So it was really interesting, and you guys can all contact later Shai to get more context on the products, and also to maybe work for a great company. Cool, so let me go ahead and introduce our next speaker, who will be the last for tonight, Tal Rosenwein. Well, I can say that when I saw his presentation at the AI Summit last month, it was really, really nice. I actually didn't know what kind of stuff you can do with the NLP, and somebody took it to a really interesting direction, and he will now speak about it. So give him a round of applause, please.
Thank you. So I'll try to make it fast so you won't fall asleep. Although my wife just sent me a message that my twins decided to get rid of their pacifiers, so I can stay up late. Okay, so just a sec. אני אעשה את הפרז אינטרוויו, קונטרול 5. Just a sec. Okay, so first thanks Toloka and Spark Beyond for hosting this and organizing it. I'm Tal Rosenwein, VP of Research and AI in at Ocam. Today I'm going to present a new feature that we're about to release soon that aims to empower people with dyslexia and reading difficulties using question answering. So a few words about Ocam before I start. So Ocam was co-founded in 2010 by Amnon Shashua and Ziv Aviram. the co-founders of Mobileye. We are located in Jerusalem. We have 400 employees. At Orcam, we're doing amazing technology that empowers people. Simple as that. We started with the Orcam II to empower the visually impaired and the blind. In the upcoming months, we're about to release the Orcam Hear, which is a hearing aid V2 that helps people with hearing loss. And the feature I will present today is part of the Orcam Learn that helps people with reading difficulties and dyslexia. Yep. Okay, so in order to support this portfolio of products, my research department consists of 5 research groups, 90 people. So it's a multidisciplinary department, starting from computer vision in the areas of object detection, face recognition, simultaneous localization and mapping. OCR supports 27 languages, ASR supports 10 languages, natural language processing and generation. We research in the area of audio-only and audiovisual based source separation and speech enhancement, text-to-speech, data and infrastructure. So the title of this slide is End-to-End Question Answering on the Orcam Learn for the benefit of people with reading difficulties. It's a joint work of many departments across the company, starting from software, hardware, software embedded, and algorithms. In what I'm about to show you, there are more than 20 neural net-based models that are running on the background, so I can't elaborate on everything, but you are more than welcome to approach me after this talk. I will be happy to share information. Okay, so let's start with the motivation. So dyslexia affects 15 to 20% of the world's population. It is a language-based learning disability, meaning that dyslexic people have difficulty to translate symbols to spoken language. So at this GIF at the center of the slide, you can have a sense of how dyslexic people experience reading. So as you can see, words are flickering, letters are substituting all the time, which make reading much challenging. And because it's so challenging, dyslexic people usually experience difficulties with other language-related skills, such as word pronunciation, spelling, and reading comprehension. So we would like to improve the comprehension capabilities of people with reading difficulties using a question answering mechanism. So one might ask, why question answering, right? So actually the answer is quite simple. Text is all over the place, right? It's written there, Spark Beyond, Exit Sign, there is text, I don't know. It's all over, right? So we can think of many cases where retrieving data from textual, from text is necessary. So let's say I'm waiting on a bus stop and I want to know when the bus will arrive. Or I'm at a restaurant and I see the menu and I want to know what is the price of a pasta dish. Or I want to retrieve the phone number from electricity bill and so on and so forth. Okay, so basically it's something that can help us in our everyday usage. Okay, so they say that a demo worth 1,000 words. So let's see. Just a sec. Just a sec. Okay, so let's think of the following situation. Okay, so let's say I'm a first to third grade student. Okay, and someone gives me this printed text. Okay, so first I would like to read it and verify that I read it correctly. And then I would like to retrieve some data from the text. So basically the Orcam Learn provides the entire experience, but today I'm going to focus only on the reading comprehension part, the second part. Okay, so this is the Orcam Learn. It's a handheld device. It has a processor, battery, camera, microphone, and speakers to communicate with the speaker. Okay, so basically the usage is quite simple. I just point at the text and the device will start immediately to read it.
Cheetahs are a type of a large cat. They're the fastest land animal on Earth. Cheetahs live in Africa.
Okay, so after I read the text, now I can start query the device. Hey Orcam, smart reading. Question, what type of an animal is a cheetah?
Cheetahs are a type of a large cat.
Question, who has strong legs?
Couldn't find an answer. Let's try again.
Question, who has strong legs?
Cheetahs are thin. They have powerful legs and small heads.
Okay, so now I think I understood what is written and I want to ask the device to quiz me, okay?
I didn't understand, but
let's play.
here is the first question. Where do cheetahs live?
So now the device asks me a question, I can answer, they live in Africa, and the device will verify it.
The answer is Africa. Here is the next question. What is the fastest land animal on Earth?
So it's cheetah.
The answer is cheetahs. Here is the last question. What do cheetahs eat?
Okay, so exit.
Please wait.
Okay, so basically, okay, so let's think together what we've just saw, or what are the modules that we need to build in order to make this thing work, or what could have gone wrong, okay? Okay, so first we need to capture the image, right? So as you can see, the light conditions are not that good, and I need the picture to be, the image to be focused. Okay, next I need to read the text. So I have here the cheetah's picture, I need to ignore it, and more specifically, the dots on the cheetah. So many OCR models will read it as either the letter O or the token period. Then I need to capture the audio and I need to transcribe it. So as you recall, I said the word cheetah, which is a word, and the device needs to transcribe my Israeli accent, okay? And last, I need, not least, I need to query the text. So I need a question answering mechanism. And finally, I need to communicate with the device. So I need text to speech, played through the speakers to the user. Okay, so what I'm trying to say is that doing textual based only question answering is challenging. Doing it in an end-to-end manner is 10 times harder, okay? Okay. So just a quick recap of what we saw. First, we capture the image, extract the text using an OCR model. Then we ask a question using our own voice, transcribe it using an ASR module, feed both outputs of the OCR and the ASR into a NLP model that returns the answer, and we play it out to the user throughout text-to-speech. So usually, all of these models run on big servers, right? But here, everything is in here, is embedded. The only thing that runs on cloud is the question answering module, which we are currently thinking whether to deploy it to device or not. We have the technology to do it. Using hard work. Really good with hard work. we write in Neon, assembly, and hard work. Everything end to end is done in Orcam. Yeah, but I can read the text, I can query the, yeah. Except for the, yeah, everything there. But, and we can put the question answering as well here if you want. We just, yeah, I'll talk to you later. No, it's weaker than your iPhone, okay? 10 times weaker than your mobile. Yeah, every printed text. You can do it on the mobile too. If you want to take a photo, you can picture this. No, we are working towards support and written. I'm not sure we need it, but yeah, it's a different topic. Okay, so our algorithms run faster than real time in a streaming fashion. The models should run with low latency, low energy consumption. In order to feed the models to device, we need to quantize and prune them. So it's lots of know-how, but at the end, it's really cool that everything runs here embedded. Okay, so let's dive deeper into the model, into the feature itself. So we start with the sensing, we'll start with the OCR. So the goal of the OCR model, so first, sorry, because I want you to go asleep fast. So here's a simplified version of the block diagram of the OCR. In practice is much more complicated. The goal of the OCR module, yeah. We support tabular data, yeah. Okay, so the goal of the OCR module is to extract the text given the input image. Okay, so here's the simplified version of the block diagram. Given the input image, as you can see here, it's one of the Cyrillic languages, newspaper. We first apply the text detector. So the text detector outputs heat map. As you can see here, green blobs is where with high probability, the text detector predicts that there is text. So as you can see, there are some false alarms here on the bottom of the figure. And next step is to, so given the output of the text detector along with the input image, we feed the line detector that predicts bounding boxes over lines of text. And next step is we want to extract the plain text, right? So we feed the output of the line detector to the OCR model and predict the plain text. But this text it doesn't have the right reading order, okay? So a few words about reading order. Reading order is hard, okay? So this is a newspaper. You want to read first the headline, the name of the newspaper and the date, and then the headline, and then the main body from left to right. This is not that hard, the reading order. Think of Japanese, where you have vertical lines, horizontal lines, some of the lines starting from left to right, the other ones from right to left. It's a really challenging task. Okay, even for human beings, it's a challenging task. Give a Japanese newspaper to a Japanese native speaker, it will take him a while to read a newspaper. It's built that way. Okay, so after we determine the reading order, we now have the plain text. It's right reading order. Okay, so we finished with the OCR module. We'll now pass to the ASR module. So the goal of the ASR module is to extract, given the audio input, extract the transcribed question, okay, speech to text. So here's a simplified version of the block diagram of the ASR module. In practice, it's more complicated. So given the audio input, I don't think you'll hear it. So basically it says, what is the name of Beyonce's alter ego? Beyonce, the singer, okay? So we feed the audio input to the acoustic model that predicts the following metrics. So x-axis represents the time, y-axis represents the alphabet, letters from A to Z. Yellow indicates high probability, and blue indicates low probability. Okay, for example, here the model predicts with high probability that the letter W was pronounced as part of the word what. So now we have this matrix and we want to decode the text. So if we apply naive argmax, meaning that on each time step we take the argmax prediction, we'll get the following sentence. Okay, so as you can see here down below, Beyonce and alter ego were misspelled. Okay, so we want to fix it. In order to fix it, what do? We apply beam search. So beam search decoding is a heuristic-based decoding, heuristic-based decoding method. We incorporate into beam search language model that we pre-trained on a large text of a large corpus of text. And basically what beam search does is prioritizing candidates according to their language model score. Word. Okay. Yeah. In practice, let's say for now, talk to me afterwards, I'll explain. It's more complicated. Okay, so basically we incorporate into beam search the language model score, and we can say, we can see, because it's okay, so basically alter ego was fixed, but Beyonce isn't fixed. It's because of the zoom. You can see it. Okay, so okay, so we want to fix it. What else can we do in order to fix it? Someone has idea? Any idea? Please help me. We want to fix it. Okay, so basically we know the text that we just read, right? We have the context. So what we do is we train on the fly, on the device itself, during runtime, during inference, we train here a language model, incorporate into beam search, and prioritize according to this model as well. Okay, so everything you saw now on the demo, a language model was built on this text, during inference on this device, embedded, and we can say that both Beyonce and alter ego were fixed. And now we have the transcribed question, which is, what is the name of Beyonce's alter ego? Okay, so basically what we have now, we have the context from the OCR, the question from the ASR, and we can move forward to the question answering module. So our models are BERT-like models, and they are fine-tuned. They are fine-tuned on a downstream task of question answering. So basically, what we do, we concatenate. We concatenate the question and the context and feed it to the BERT model that has two outputs, two heads, start and end of span prediction. Each of the heads output is normalized to perform a probability distribution. And so here's an example. Here's the context. Here's the question. You can see it, but the question is, what is the name of Beyonce's alter ego? And we get the two heads, okay? The outputs of the two heads. We cross multiply them to perform this matrix. X-axis represents the start index. Y-axis represents the end index. Okay, yellow indicates high log probability. Blue indicates low log probability. So now we wanted to extract the span, the answer span. So what we do, we take the argmax such that the end index is greater or equal to the start index. So this is how it looks when we look at the log probabilities. But when we look at the unknown probabilities, things are much more clear. Okay, so now we have the span, we map it back to tokens, and we get such affairs, okay? But the user, we want to perform a long form answer. Okay, so we have some kind of heuristic that returns a larger context, which is played back to the user throughout a text-to-speech engine, which I will not elaborate, but whoever wants, I can speak for hours about it too. And this is the text that will be played to the user throughout the speakers. Okay, so basically what I showed you today is an end-to-end question answering on Occam Learn for the benefit of people with reading difficulties. The thing I wanted to highlight is that when you use sensing, when you do it in an end-to-end manner, things are much more complicated, much more challenging, because you have issues with sensing. Okay, so making things work seamlessly is hard, it's challenging, and this is what we do in Occam.
Why did you decide to do it in a handheld device, embedded, and not going to the maybe first in the internet, online? Most of the learning is done online these days.
Wow, that's a great question. Okay, so basically, it's a good question. Basically, when you interact with the dyslexic people, usually they also have ADHD, so you don't want them to see screens. And in addition, the goal of, we think that this device we're soon about to put it in schools where the phone, they won't put phones like in exams, or so you need a standalone device in order to attract the dyslexic people. Yep.
So now, as I understand, you're working mainly with kids. Is there a plan to work with adults and, for example, produce a summary or a main idea of the text?
Yeah, so basically we're working towards like high school and students as well in these directions, exactly these directions. Want to ask and I will repeat?
Why does the reading audio matter?
Okay, so the question is why reading audio matters. Let's see. I'll give you an example, it will be better. Okay, so let's say that the span was if you can see it on the iPhone as well, like reading, they don't do the reading order that well. So basically, if I didn't have reading order, this line was concatenated with this. Okay, and then you could have like things would get really messy. You need some coherent text to be read, and in addition, you want the device also always can read the text to the user, so you must do it in the right way. Yeah.
Is there something, or is there an Occam system or device for the blind, or for the for vision impaired people? Does it look different? It's glasses?
Yeah. Okay. Understood the question. Yeah. So the Occam Eye is for the blind and visually impaired. Basically, we have a mount for glasses. The device itself is smaller. It's like half of this size. And using magnets, you can put it like on, attach it to every glass you want, and then you can use it whatever you want.
We're going to have one last question from Zoom, yes, and afterwards you'll have a chance to approach or personally and get answers, okay? So the question is QA BERT a modified version of BERT?
What?
Is QA BERT a modified version of BERT?
Yeah, it's not necessarily BERT as BERT, but yeah, version like encoder. Okay, let's say encoder. BERT is an encoder, so we use encoders.
Thank you. So, just remain seated for one last presentation. I'm promising it's going to be a lot shorter than the other ones, a minute or two. And originally we wanted to do a panel discussion, but we also wanted to be fun. So after I'll go through 2.5 slides, you will have the chance to come and ask questions and network with everyone here. So, and then you just get the choice to stay or leave or whatever. So, we saw today really interesting applications of AI, and some of them also presented Toloka under the hood. And just to give a bit of a context that we're doing not only data labeling, but we're actually covering already a big chunk of the entire machine learning value chain. So we actually established already the data annotation, which we are pretty advanced in, but we're also now focusing on model training, deployment and evaluation, and also planning to start with the data acquisition management and go to exploration, preparation, and retraining and annotation. So basically, we're happy to unite the entire machine learning value chain. And in order to give you some sense of the models that we already have, you will get the presentation later. So basically, you can scan this QR code. And if you remember earlier when Itamar presented, we spoke about the sentiment analysis model for tweets. So this is actually the direct link for that. So you're welcome to try it yourselves. And also you can put on inquiries for us for models you want to be applied that we can help you develop and maybe to power your models as well with the teams that we have inside. So with that being said, this is a black screen, so I would like to say thank you for everyone for coming. And again, mentioning we will not have the panel discussions, but you have the chance to come to the speakers that are here. You can ask them questions and just do as you like. Thank you for coming.
תודה. שלו. ראיתי אותך עוד ברגע של השמירה הולך לקחת פיצה. כן, לא, היה גם לי קשה ועמדתי כל הזה. ממש קשה. Whoa. Yeah, just stand a bit. Oh my god. Yeah, it was a bit.
So we done, you think?
Yeah, so we did. They don't do the panel.
So that's okay.
That's it. I guess so. Yeah, it was really good. Like, yeah.
Nice work.
Yeah, Sagi, our CEO, just told me that he was really impressed. Yeah.
Go for it.
Yeah, it was loud. Take care.